Hi everyone. All right, so in the last unit we talked about plate tectonics, and now I want to ask the question, how do you figure out the plate tectonic history of an area? Virginia, as it turns out, has a very rich plate tectonic history. Well, what you basically have to do is look at the geologic evidence. It's sort of like a detective. They start to go around, they look at clues, and then they eventually try and figure out, okay, what kind of evidence we have. All right, so let's take a look at different types of folds and faults. And, I understand that if you take a hammer on a rock and you bang on it enough, eventually it's going to break. What a surprise to me was when I learned about geology was that if you take a rock, you can actually bend it. In order to do this, you have to heat it up first, okay, and then you can get it to bend. And that's what's going on here. And I've drawn some side views through some rocks that have been folded. Okay, the one that's on the left is called a syncline, where the rock's essentially sinking into the ground. That's the way students have told me that it's easy for them to remember it. And then you've got anticlines, where the rock is sort of popped up in the center there. Okay, one of the ways that you can tell whether you have an anticline or a syncline, okay, is by looking at the age of the rocks. And we talked about this in the fossils unit. The oldest rocks are going to be on the bottom if they haven't been disturbed, but when they're folded, the oldest rocks wrap around in a syncline to the sides, and the youngest rock gets squished in the middle, right here. On an anticline, it's the exact opposite. The oldest rocks get compressed at the bottom and into the middle, whereas the youngest rocks, okay, are present on the side of the folds. And you rarely find just one anticline or syncline. In fact, the Appalachian Mountains are made up mostly of a fold belt, where you alternate between all anticline and syncline layers that you have here. In order to form a fold belt, you have to compress the rocks. Compression, where rocks are squeezed together, is the only way that you can do it. You can try pulling on rocks or rotating them, but you won't form a fold by that method. And that's going to be important in another lesson that's coming up later. All right, I'm going to skip this rule of dips. Some of you may try another activity later. Basically, arrows are shown on folds to indicate the direction which they dip. So if they dip towards the center of the fold, it's called a syncline. If they point away, it's called an anticline. Now let's talk about faults. Like I said, if you apply stresses to rocks, sometimes they don't bend, they break instead. And so the first diagram here, the one that's shown here, has what we call a hang wall, all right, because there's one block that is hanging over the other. And this is called a reverse fault. I'm not sure where they got these names from. I might have changed them around. It turns out we've got a lot of reverse faults that are present here in Southwest Virginia. And the stress that produces this is compression. The rocks are obviously squeezed together like this in order to get them to crack like so. In this second diagram here, we have what's called a footwall. So this block is moved down relative to the other, and it's like a ramp. So if these blocks were big enough and you were standing here, you could just walk up on top of the other one. And these types of faults are called normal faults. The only way that you can produce a normal fault is a result of the only way you can, sorry about that, the only way you can produce a normal fault is a result of tension. So you have these two blocks and they have to be pulled apart like that. All right, there's one more type of fault that I want to talk about, and that fault is called a strike-slip fault, and that's shown in this diagram here. All right, there's no vertical movement along the fault plane. Instead, the blocks sort of slide horizontally past each other. And because there's no vertical movement, you won't have a footwall or a hang wall. This type of fault is called a strike-slip fault. Some of the most famous faults in the world, okay, are strike-slip. For example, the San Andreas out in California. And the type of stress that produced that is called shearing. Now that we've talked about the different types of folds and faults, I want to talk about the physiographic provinces of Virginia. We mentioned these in the fossils unit. Remember I said there's the Appalachian Plateau, Valley and Ridge, Blue Ridge, Piedmont, and Coastal Plain. I even gave you a fun mnemonic to remember, a very big, powerful Corvette. What I want to do is talk a little bit more about each one of these provinces, starting with the Appalachian Plateau. Okay, and this is in the westernmost part of the state. You think of the western part of Virginia, and you think of coal. It's the most important energy resource that we have. And coal is formed in a sedimentary rock environment. So you get sandstones, shales, and limestones formed associated with it. Then you have structures. For example, if you look on this cross section here, you'll notice that there are flat-lying rocks to the farthest west. And the reason why these rocks are so flat is because they're so far west that the impact of continents slamming together like Africa and North America weren't experienced in these rocks. And the age of these rocks goes anywhere from about 290 to 355 million years old. The second physiographic province of our state is the Valley and Ridge. This is a great place to go if you want to look for fossils. I often go along the Valley and Ridge because there are sedimentary sandstones, shales, and limestones that commonly have these fossil forms. If you look at the cross section, you'll notice that the rocks are folded here, and there's also some cracks that are present. Those are faults. And what we notice is that in some cases the one rock layer has been thrown up on top of another, but in this case it's been eroded away. The age of the rocks in the Valley and Ridge are anywhere between 250 to 545 million years old. Then we get to the Blue Ridge. If you've ever been on top of the peaks of Otter, you've been in the Blue Ridge Mountains, or maybe the Phoebe Needles. And in the peaks of Otter, you have old volcanoes, so those are obviously igneous rocks. In some cases, they've been deformed and formed metamorphic rocks like gneisses. If you look at the side view, you'll notice that there are cracks. There are faults that border both the west and east side of the Blue Ridge. These are reverse faults. They normally should have hanging walls, but they've been eroded. And the age of these rocks is anywhere from about 575 million to 1.5 billion years old. Some of the oldest rocks in our state are found in the middle of our state, and sometimes that confuses students. What you should do is don't think of Virginia as it is today. Think of Japan off the coast of Asia. That's what Virginia looked like if you go back 500 million years. We had a volcanic island arc off the continent of North America, and there was a shallow sea, like the Sea of Japan today, between Japan and Asia. Then we get to our province, the Piedmont. On top of Bald Knob and Grassy Hill, there are igneous and metamorphic rocks. There are also reverse faults to the west and normal faults to the east. And we have geologic age anywhere between 180 million to 1.5 billion years old. Coastal plain is next. This consists of loose sediments. Because it's loose sediments, there are no structures that are present in these. And the geologic age goes anywhere from 0 to 135 million years. By the way, I want to mention that the graphics that you see here were produced at William and Mary College, and I do have their permission to use these graphics in my lectures.